Scientific method is an empirical method of knowledge acquisition, which has characterized the development of natural science since at least the 17th century, involving careful observation, which includes rigorous skepticism about what one observes, given that cognitive assumptions about how the world works influence how one interprets a percept, formulating hypotheses, via induction, based on such observations, experimental testing and measurement of deductions drawn from the hypotheses, and refinement of the hypotheses based on the experimental findings. These are principles of the scientific method, as opposed to a definitive series of steps applicable to all scientific enterprises. Though there are diverse models for the scientific method available, in general there is a continuous process that includes observations about the natural world. People are naturally inquisitive, so they often come up with questions about things they see or hear, and they often develop ideas or hypotheses about why things are the way they are. The best hypotheses lead to predictions that can be tested in various ways. The most conclusive testing of hypotheses comes from reasoning based on carefully controlled experimental data. Depending on how well additional tests match the predictions, the original hypothesis may require refinement, alteration, expansion or even rejection. If a particular hypothesis becomes very well supported, a general theory may be developed. Although procedures vary from one field of inquiry to another, they are frequently the same from one to another. The process of the scientific method involves making conjectures, deriving predictions from them as logical consequences, and then carrying out experiments or empirical observations based on those predictions. A hypothesis is a conjecture, based on knowledge obtained while seeking answers to the question. The hypothesis might be very specific, or it might be broad. Scientists then test hypotheses by conducting experiments or studies. A scientific hypothesis must be falsifiable, implying that it is possible to identify a possible outcome of an experiment or observation that conflicts with predictions deduced from the hypothesis, otherwise, the hypothesis cannot be meaningfully tested. The purpose of an experiment is to determine whether observations agree with or conflict with the predictions derived from a hypothesis. Experiments can take place anywhere from a garage to CERN's Large Hadron Collider. There are difficulties in a formulaic statement of method, however. Though the scientific method is often presented as a fixed sequence of steps, it represents rather a set of general principles. Not all steps take place in every scientific inquiry, and they are not always in the same order. Some philosophers and scientists have argued that there is no scientific method. They include physicist Lee Smolin and philosopher Paul Feyerabend. Robert Nolla and Howard Sankey remark that, for some, the whole idea of a theory of scientific method is yesteryear's debate, the continuation of which can be summed up as yet more of the proverbial deceased equine castigation. We beg to differ.